Well, so our second part of chapter 4, that's focus on two points from the chapter 4, studying the characteristics of a market demand and using market demand to measure benefit received. So let's start with the market demand. As you know, market demand is a sum of all the individual demands in the market. Market demand curve relating the quantity of goods that all consumers in the market will buy to its price. So here is an example. If you look at it, there are three individuals like individual A, B, and C. And they have a different demands at the different prices. Like if the price is $1, individual A demands 6, individual B demand 10, and individual C demand 16. And altogether, if the market is only composed of these three individuals, so the overall market demand is 32 at the price of 1. And same when we study if the price is $2, how much A is willing to buy, like 4, B by 8 by B, and 13 by C, and altogether it's a 25. So we see here these are individual demands. These are individual demands for each individual, and you can see these individual demand. When we sum up all these together, so we get this is the market demand. So market demand is a horizontal. Now we use the word horizontal summing up. The reason behind the horizontal summing up is that the price variable is stay like the individual demands price, but the quantity variable is going to be add up, and that's why we call it as a horizontal summing up. Now you can see the demand curves like as well, like the D1 is reflecting, DA is reflecting a demand curve for individual D, DB is for demand curve for individual B, and DC is a demand curve for individual C. And when we horizontally summing up, we get the market demand curve, like we see at the price of $1, the total overall demand is 32 somewhere, and then at the price of 2 we see here that the demand is 25. So we can see here that's a 25, so on. So we just add up the demands of each individual, or sum up the demands of each individual in the market to make a demand curve. So two important points for the market demand curve. The market demand curve will shift to the right as more consumers enter the market, and we all know that the demand curve shifts right or left with the increase or decrease in the number of buyers. So that's a demand curve is going to shift because of increase or decrease in the number of buyers. The second point is important. The factors that influence the demand of many consumer will also affect the market demand. So definitely when we discuss like the income, like the price of related goods, substitute or complement, or other expectations, and all these things that affect or shift, cause a shift in the individual demand curve, also cause a shift, because you know the market demand is a sum of. So if the individual demands are changing, the demand is changing because of any factor, so definitely the market demand is going to also change by the same factor. So the aggregation of individual demand into market becomes important in practice when market demands are built up from the demands of different demographic groups or from consumer located in different areas. So we can construct a demand curve for different ethnic groups or demographic groups, as well as we can make a demand curve for different locations, or like a cities or regions or provinces. So that's the way that we can calculate. Similarly, like we discussed in our previous chapter, demand curve for the individuals, and we also discussed about the elasticities. So same the case here is for the demand, for the market demand, denoting the quantity of a good Q and its price P. The price elasticity of demand is delta Q over Q bar, which is percentage change in quantity demanded divided by delta P over P bar, which is a percentage change in quantities, percentage change in price. So when we calculate the price elasticity of demand, we get a product of a price ratio, the price over quantity. That's price divided by the quantity multiplied by the slope, inverse of the slope of the demand curve, percentage change in quantity divided by percentage change in price. So when the demand is inelastic, the quantity demanded is relatively unresponsive to change in price. As a result, the total expenditure. Now we want to relate it with the expenditure. So if the demand is inelastic, relatively unresponsive to the change in price, as a result, total expenditure on the product increase when the prices increases. For example, we are talking about a product which is like a medicine or a salt, so because the quantity is inelastic, it's not changing so much with the change in price. So if the price increase, so definitely the expenditure on this product is going to increase. And if the price decrease, the expenditure will go decrease. On the other hand, when the demand is elastic, so when a demand is elastic, total expenditure on the product decrease as the prices goes, because the consumer is buying less of it. So for that reason, if the price goes up, the expenditure goes down. So there is another type of a demand curve, which is what we call it as a unit elastic, or such a demand curve in which the slope of the curve is such that whatever the change is in quantity demanded is equally by the change in the price. Whatever the changes in quantity is change in the percentage change in the price, cause a same change in percentage change in quantity. And for that reason, wherever we calculate the elasticity, it is always 1, and that type of demand curve is called as a unit elastic. So in that case, the expenditure is not going to change, because the expenditure, when the price elasticity of demand is 1, at every price the expenditure is constant along the demand curve. So expenditure is not changing, it's the quantity is matched by increase or decrease by the price increase or decrease. And by this way, what is happening is that always we get the elasticity equal to 1. Now, if there is a speculative demand, means that people are expecting that the price will increase. So by this way, if they are buying or selling something, so that type of called is a speculative demand. A demand driven not by the direct benefit one obtained from owning or consuming a good, but instead by an expectation that the price of the goods will increase. So in this case, we see that price elasticity and the consumer expenditure. If we look at expenditure, and as we just mentioned, for inelastic demand, if the price increases, expenditure increases. If the price decreases, expenditure decreases. On the other hand, if it is a unit elastic, so there is no change, as we mentioned, exactly the percentage change in quantity is matched by the percentage change in price. So by this way, they always get a 1, and the revenue is not going to affect, or the expenditure is not going to affect by this change. And if the demand is elastic, it goes in an opposite direction. Like if the price increases, expenditure decreases. If the price decreases, expenditure increases. So it means they move in an opposite direction. So here is an example. Like we have two different types of demand. One is a domestic demand, and we represented here with the DD, domestic demand, right? So the quantity domestically demanded is 1430 minus 55p. So this is our domestic demand curve, or a domestic demand equation. The other one is a demand for export. So what we are talking here is a wheat, and wheat export from US. So this is the demand curve for the domestic consumption, and this is the demand curve for export. Now, as we want to know what is the total demand, the domestic as well as the export, so what we did, we add up, and this plus this figure. So when we add up, so we know that it is 1430 plus 1470, so it's going to be 2900. And here is minus 55 and minus 70, so it's going to be 125p. So this is our total demand equation, world demand. So we can graphically, we can also add. You see here, this is our domestic demand curve. This is starting from CD. CD is our domestic demand curve, and we see that AF is our total demand curve, and this dotted line is our export demand, sorry, this one is our export demand, CD is our export demand, and this dotted line from this point to this point, although it's starting from A to B, is our domestic demand. So AB is our domestic demand curve, CD is our export demand curve. When we combine, we get a curve like AF is our total demand curve. Now there is a kink. Now why there is a kink? Because above the price of $22 or $21, so $21, above the price of $21, there is no export demand. And so for that reason, this portion, which is from A to E, is only a domestic demand over the price of 21. But after, when the price goes down from 21, the export demand is going to be also added in it. Now there is an example here quoted in your book is the demand for housing in Canada. So there are in US. This book is published in US, so they have a data for US. There are significant differences in price and income elasticities of housing demand among subgroups of the population. So they divide the population into different subgroups and see that how much the elastic the housing price is to the housing price elasticity of housing demand. So we see here the single individuals price is quite elastic, negatively inelastic. The demand is quite inelastic, negatively, and income elastic, also inelastic, but positive. Married head of a household age less than and 31 child, the elasticity is improving, not is still inelastic, but it's improving as compared to single individual. But income elasticity is decreasing in that case. Married age between 30 to 39, two or more children. In this case, again, the elasticity is less as compared to married with one child or less than age of this. So married age 50 or elder one. So you see that inelasticity is increasing. So these guys are more towards buying the house as compared to the one married with a one child. So we see at the old age people are more concerned without any effect of a price to buy a house. So in recent years, the demand for housing has been partly driven by speculative demand. Speculative demand is driven not by the direct benefit one obtains from owning a home, but instead of this. Same is the case we can see here for gas. This graph is very interesting. If you note that the size of the balls, these round balls, is reflecting that how much they are consuming. So would higher gasoline price reduce gasoline consumption? So this figure provides a clear answer, most definitely. So gasoline price and per capita consumption in 10 countries. The graph plots per capita consumption. So it's a per capita consumption by the gallon by this balloon. So per capita consumption is highest in Canada, and overall it is very high. Gas or a diesel for transportation gallons per capita, so it's very high as compared to if you look at the countries in Europe, and we can see this from this point as well. Like in Europe, you hardly find any person living in city have a mini trucks or a trucks like what we have here in North America. Everyone is willing to buy the biggest cars with large engines, and consumption is very high as compared to people living in Sweden, Norway, Austria. These are small countries and not so small, but even they are very living in a very concentrated cities, and there is not a lot of consumption of oil is there, and their public transports are very efficient, so that's the reason they are consuming less. The next concept is a consumer surplus, and we know that consumer surplus is a difference between what the consumer is willing to pay and what the actual price he is paying. The difference is a consumer surplus. So difference between what the consumer is willing to pay for a good and amount actually paid. So that's a difference. So as you know, over the demand curve, if you look at each consumer's willingness to pay is different. So the highest willingness to pay consumer is the first buyer, and then as the willingness to buy is decreasing, so the buyer is moving towards that, and we reach to the point where we can find out a marginal buyer, the buyer which is at the very last point, and marginal buyers are normally have a no surplus. Consumer surplus is the total benefit from the consumption of a product less the total cost of purchasing it. So here the consumer surplus associated with 6 concert tickets purchased at a $14 per ticket is given by the yellow shaded area. So price is $14. The willingness to pay for this ticket, the first ticket holder has a willingness to pay for 20, the second is 19, the third is 18, and then 17, 16, and 15. So we see each the one who is willing to pay like a 20 and the price is 14. So the first one has a consumer surplus of 6, the second one has a willingness to pay 19, the price is 14, so 5. And so by this way, overall all these 6 ticket holders are going to get it a $21 consumer surplus over the consumption. In a generalized form, if it is a demand curve, and we can find out there for the market as a whole, consumer surplus is measured by the area under the demand curve as a market, under the demand curve and above the price line. So this is our demand curve, so area under the demand curve and above the price. So this area, which is yellow shaded area, and it is a triangle, so we can find out the area of a triangle. Area of a triangle, we all know that we have to find out in a geometric formula, base into height into 1 by 2. So this is the formula we are applying here. 1 by 2 into 20 minus 14 into base is 65,000, right? 6,500. So we get it, the consumer surplus is 19,500. Consumer surplus measures the aggregate benefit that the consumer obtained from buying goods in a market. When we combine consumer surplus with the aggregate profit that producers obtain, we can evaluate both the cost and the benefits, not only of alternative market structures but of a public policy. So consumer surplus is a concept which is important, and it helps us to understand the public policy measures. Sometimes the government design policies in order to favor consumers, so they try to increase the consumer surplus by setting the price below the market price, or they can increase the here is an example, the value of a clean air, so although there is no actual market for clean air, people do pay more for houses where the air is clean than for the comparable houses in areas with the dirty airs. So although there is no direct market, but indirectly we are paying in a way that if you want to buy a house in a more cleaner areas where the air is more clean and everything, then as compared to the place where it is the air is dirty, the price difference is the difference because of the air quality. So the yellow shaded triangle gives the consumer surplus generated when the air pollution is reduced by 5 parts per 100 million of nitrogen oxide at a cost of 1,000 per part reduced. So the surplus is created because most consumers are willing to pay more than 1,000 for each unit reduction of nitrogen oxide. So this is all our part 2. Now we will cover the part 3 and part 4 for this chapter in order to cover out this topic of market demand.